أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه وسلم. We give thanks to Almighty Allah, the cherisher and the sustainer of the universe, the one who taught men by pen. We give thanks to Allah for making us Muslims. We thank Allah for sending Prophet Muhammad sallallahu alaihi wasallam as the messenger who guided us to know that searching for knowledge is essential. So this is I am wk2 Ridwan Babatunde, your chemistry teacher, your tutor, and your anchor. So I shall be talking about hydrogen and its compounds, that is hydride, as the wk2 work for this third term scheme of work, hydrogen and its compounds. Here we shall be looking at the hydrides basically as the compounds of hydrogen. In the first place, we shall look at the occurrence of hydrogen configuration and oxidation number. Hydrogen, it is the number one element on the periodic table. It is a non-metal. It is a gas. What does it mean? As it is, hydrogen, meaning water former. It was named as such by a scientist called Anthony Lavoisier. Anthony Lavoisier named this gas as such after the discovery made by Henry Cavendish in 1766. Henry Cavendish found that the gas, hydrogen, was flammable and that it burned in air to produce water. As you can see in the equation below, H2 gas plus O2 giving us H2O. Hydrogen as it is, if you want to look at its occurrence, it makes up about 1% of the Earth's crusts. It has about 0.01% in the atmosphere and is widely distributed in combination with other elements. It is a constituent of most organic substances like proteins, carbohydrates, and fats, which are three of the four essential biomolecules that make up organic matters or living matters. Hydrogen has only one electron in its outermost shell. Looking at its electronic configuration, it has 1s1 as its configuration. Hence, hydrogen needs one other electron to complete its duplet structure. That is, to attain a stable electronic configuration, it needs to, most commonly, it gains one more electron. So we can say hydrogen resembles helium in its configuration. Hydrogen has an oxidation number of +1 most commonly in most of its compounds, except in hydrides where it is a -1. Hydrogen as it is, if we want to prepare it in the laboratory, how is it prepared? So that will take us to laboratory preparation of hydrogen. If you want to prepare it in a small quantity, quickly you want to make use of it. So there are three basic methods by which hydrogen can be prepared in the laboratory. They are: number one, action of zinc on an acid; number two, action of sodium on cold water; number three, action of red hot iron on steam. Now, let's start from the very first, number one, which is the action of zinc on an acid. Dilute hydrochloric or tetraiosulfatic acid. They attack metallic zinc with the liberation of hydrogen gas. In this process, no heating is necessary. We can have the equation as we have in the number one here. Zn, that is solid form of zinc, maybe in powdery form, long form, or granule form, the one that will make the reaction to be faster is it is faster when you use, the powdery form of zinc. As we know, surface area helps rate of a chemical reaction. It's a very important factor. So what I'm trying to emphasize is that if you want to have more hydrogen gas produced, it's better we use the powdery form of zinc. So being mixed with hydrochloric acid or H2SO4, then we are going to have zinc chloride. This is supposed to be ZnCl2, so plus H2. That is, hydrogen gas will be evolved, will be released. The second way of preparing hydrogen in the laboratory is the action of sodium on cold water. Sodium on cold water. So as we know, sodium is a very reactive metal. So this is a vigorous reaction where only small piece of sodium is needed. It's not only sodium that can be used there, we can also use other reactive metals in group 1. Other reactive metals can also perform this function. Lithium, potassium can also be used. On cold water, they would readily release what? Hydrogen gas. Sodium liberates hydrogen gas from cold water. This reaction is very vigorous and it needs to be carried out with a very great care. Because it can cause an explosion. That's why we say it's a vigorous reaction. The third way of preparing hydrogen in the laboratory is the action of red hot iron on steam. This reaction is reversible. That means it can go forward, can go backward. But we need to set the condition that will favor the production of hydrogen gases, since it is the hydrogen gas that we want to produce. So iron that is red hot would readily liberate hydrogen from steam. So what shall we produce after that? We are going to have iron 2 diiron 3 oxide produced, that is Fe3O4. It will be formed. Then you also have your hydrogen gas being released. The diagram below shows a setup of how hydrogen gas can be prepared in the laboratory, especially from the first method, that is the action of zinc on an acid, any of the inorganic acids, especially the HCl or the H2SO4. You fill your acid inside this tissue funnel, as you can see, this tissue funnel here. You fill it inside right here. Then you have your round bottom flask, as you can see, or a flat bottom flask if you desire. So you have the piece of zinc powder or piece of zinc granule. As the dilute hydrochloric acid is getting to the zinc, there will be evolution of hydrogen gas, which will have to be collected over water, and you are going to have hydrogen gas being produced up here. To be produced up here. So these are the laboratory preparations of hydrogen gas as it is. So that means if you want to prepare, if you need hydrogen in the laboratory and it is in a very small amount or volume, so we can use any of these methods to get our hydrogen. Moving forward, there are some cases whereby we need to prepare the hydrogen in a very large quantity. So that will now take us to industrial preparation of hydrogen gas. In case the volume of hydrogen we require is great. So these are the methods that we can also use when it comes to preparing hydrogen gas on a large scale. First and foremost, we can use a process called Bosch process. This Bosch process involves production of large quantities of hydrogen by using cheap raw materials. The raw materials that are used are namely coke, that is the form of carbon, then steam, that is water, If this is to be carried out, it involves two different steps. Two different reactions take place there. If you want to produce hydrogen in the industry from a process we call Bosch process, first we make sure that the steam is passed over red hot coke at about 1200 degrees Celsius. This first reaction is endothermic. What does it mean? It involves supply of great amount of heat into the system. So passing steam over red hot coke at about 1200 degrees Celsius will now lead to a mixture of carbon-2 oxide and hydrogen gas. This mixture is known as water gas from your knowledge of carbon and its compound. So it can come in an exam whereby you will be asked, what are the composition of what we call water gas? It is actually carbon-2 oxide and hydrogen gas. Now, that is the first step in the industrial preparation of hydrogen gas using Bosch process. The second step, that is the second reaction, it involves reduction of steam to hydrogen by carbon-2 oxide. This is exothermic reaction. It involves the release of great amount of heat energy. It involves the release of great amount of heat energy. So in this reaction, we are going to have the steam being released. The reduction of steam to hydrogen by carbon-2 oxide, as you can see in this reaction, we have the steam, we have CO plus H2. The H2 is the partially formed hydrogen. But when it is in combination with CO, we call it water gas. Now, the CO from the water gas will now reduce the steam, additional steam, that is H2O here, so that we can have more hydrogen gas being formed. Then we are going to have CO2. The CO2 here can easily be taken away by passing it over soda, that is caustic soda. If actually we want to remove the CO2 from the mixture, so we can simply dissolve it inside water or using other solvents such as caustic soda solution, the CO2 that we have in the second reaction here. Then any unreacted carbon-2 oxide can be absorbed in a solution of ammoniacal solution of copper 1 ethanoate. So this reaction takes place, this second part of a Bosch process takes place at about 450 degrees Celsius. We use iron 3 oxide or chromium 3 oxide as a catalyst. Now the other process by which hydrogen gas can be produced on a large scale is from methane. That is the methane that is obtained from a natural gas. If you obtain a methane from a natural gas, so this is cheaper and is used to replace Bosch process. Bosch process is expensive. So the mixture of carbon-2 oxide and hydrogen gas that is produced in this process is referred to as synthesis gas. As you can see, we have 2A here, methane combining with your steam, giving us CO plus 3H2. So the mixture of CO and 3H2 is what we refer to as synthesis gas. It has a second stage that is exactly the same as the water steam reaction from Bosch process, as we have in Bosch process. The second stage of this preparation of hydrogen from methane, it resembles the second stage as we have in the Bosch process. Hydrogen can also be released in a large quantity here. The third process is by employing any of the electrolytic methods. That is, you can use electrolysis of brine. Hydrogen is one of the byproducts there. We can have electrolysis of dilute sodium or potassium hydroxide. So we can have hydrogen gas being released in large volume here. So besides that, we have what we call hydrogen and the activity series. Hydrogen and the activity series. What do we mean by this? Hydrogen and the activity series. We mean the activity is a very useful guide we try to look at how hydrogen can be what? Can be released when you have some metals reacting with water or acid. You know, water contains hydrogen. Acids contain hydrogen. So if you now react some metals with water or acid, hydrogen can be released. Some cannot release hydrogen. Now, for instance, in the laboratory preparation of hydrogen, we saw that some metals could displace hydrogen from water and acid. So these metals, they are very reactive metals, like potassium, sodium, calcium, magnesium can also do that, aluminum can do that, zinc can do that. But metals like copper, mercury, gold, silver, so they do not like kind of show any reaction when they react with what with cold water or steam, especially when it comes to releasing hydrogen. So this activity series is here to show us, or is a kind of a reaction, is as a useful guide to the chemical behavior of metals and their compounds when it comes to releasing hydrogen from acids and water. Hydrogen is placed in the activity series to indicate the position it's going to occupy. Some metals that are above hydrogen in the series, this is the series here. You have from lithium, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. Hydrogen is pushed, and as you can see the two double line up and down to show the position of the hydrogen there. Copper, mercury, silver, platinum, and gold with their symbols. Now, those metals that are above hydrogen in the series, they can what? They can displace hydrogen from its acid or from water. But those that are lower, they cannot what? They cannot. Generally, metals that are high up in the series are very electropositive. They are very active chemically. Metals that are low in the series, like copper, mercury, silver, platinum, they are what? They are less active. So any metal will displace those below it from a solution of their salt. For instance, it's not only that the metals that are above in the series can displace hydrogen, they can also displace metals that are lower. Any metal that is higher than the other metal in the activity series, such a metal will have the ability to displace the other metal from a solution of what? Of its salt. So meaning that if you have, for instance, if you have calcium and you have a magnesium chloride, it is easy for calcium to what? To displace magnesium from solution of what? Of its salt. So then calcium will take its place. Besides that, with the piece of metal should be cleaned if that is when you have already got what you want to get. So moving forward, what are we trying to say as regards this activity series of metal is that it helps us to know the kind of metals we can react with acid or what, or water when it comes to hydrogen preparation, hydrogen gas preparation. So now, as you can see in this activity series, one arrow, it is at the left hand side, it's pointing upward. The other arrow is at the right hand side, it's pointing downward. So the arrow pointing upward shows increasing electropositivity, while the one that face downward shows decreasing chemical activity of the what? Of the element here. What does it mean? The arrow pointing upward shows increasing electropositivity. So as you go up, so electropositivity increases. The other one, as you come down, chemical activity decreases. So inshallah, I would like to halt here. We shall continue in lesson 2 with the physical properties and chemical properties of this hydrogen gas that we are talking about. What are the physical properties? What are the chemical properties? Apart from that, we also look at some of the reactions in the test you can use to identify it. It uses and some of it hydride. Till we meet again, I will say Assalamu alaikum wa rahmatullahi wa barakatuh.